That was great, I enjoyed watching that.
It was a really good super lab.
Yeah. Did you find out what you made in the end?
Oh, I did. It was trinitrotoluene.
That's TNT. Where did you leave it?
Oh, in your car.
In my...
Oh, it's fine. You got 3 cars as well. 2 now. Sorry about that.
I'm going to have to get you back for that.
It's fine, insurance.
I guess. Anyway, so it's the first video of chemistry. I'm just going to let that blow over.
Yeah. So it starts with things about the atom, some of which you've covered in GCSE and some of which you haven't.
So we'll ask the first question, what makes up an atom?
So I've drawn one corner up here, and it's made of protons, neutrons and electrons. These are all very small, but electrons are by far the smallest.
So the physical properties of these first, let's start with charge.
Alright, I think that's a great plan. So protons are positive, electrons are negative, and neutrons have no charge.
Now if we express an element as a X, this could be any of them whatsoever.
Yeah, the hydrogen, lithium, anything.
You notice in the periodic table, you've probably done at GCSE, you should have done, you'll have a number at the top, I'll express with a K, and a number at the bottom, I'll express with an L. Those are random letters.
Okay.
What do both of these numbers mean?
Well, there's the atomic number, and then there's the mass number. Now, the bottom one is the atomic number.
And that can also be called the proton number. And when you call it the proton number, you can guess what it means.
The amount of protons in that element, and that number never changes.
And where do we find protons and neutrons?
You find them in the nucleus, which is in the centre of the mass.
Yep. And then the top number, called the mass number,
is the amount of neutrons and protons. These are the heavy things. The electrons are actually so much smaller, only 1/2000th of those two.
Yep. We say that neutrons are neutral, but they do have a mass, just the same as protons. So don't think when you see 0 that it's 0 for everything. They're almost massless. They're not. They're the same as protons.
They're quite chunky, really.
This N plus P, just in case you think it's nitrogen plus phosphorus, it's not. I'm saying neutrons plus protons, just to be
Always got to be careful.
So that's the mass number and that number. So how do these things change if I have, say, an isotope?
Well, an isotope is a different amount of neutrons, which is a strange thing. It doesn't really affect the properties, it just affects the mass.
You've probably heard that you can get isotopes of carbon. You can get carbon-12, carbon-13 and carbon-14. All of these have the bottom number, which is the proton number of 6. That means they all have 6 protons in the nucleus.
And that never changes, but the top number does change. That means neutrons must change.
So, if I ask you how many neutrons are in each of these isotopes, because that's what they are when they're the same thing but with different mass numbers.
It'd be 6, 7 and then 8.
And how did you work that out?
It's just a difference between these two numbers, and that would be the neutrons.
Very good. So, ions is another thing as well as isotopes.
Yep, and I'll tell you that fine for no charge.
Thank you. Thank you.
It's all about the charge of atoms, which can be positive and negative. The only thing that changes is the electrons, because the protons don't change. So instead of getting more protons to be positives, you just get less electrons. So if we start again with a element, say, chlorine.
Chlorine is a good answer. They like to have negative chlorines.
17 bottom and 35 at the top.
35. In your table it's 35.5. We'll just leave it as 35 for this exam.
It's an average, but we'll get onto that in a bit.
Yeah. We'll also get on to how you know what charges on everything a bit later on, another chapter.
Yeah. So to start with, it has 17 protons and 17 electrons. That's what it is in an atom. But what happens if I add, say, 1 negative charge, like that blue line there?
Well, that negative charge means it's gained 1 electron, because electrons are negative. If it gains 1, it's going to become 1 negative. If there was a 2 in front of that, it would be 2 electrons. That means it's gained an electron. If it's had 17 to start with, there's going to be 18 electrons. There's still going to be 17 protons.
Because that never changes.
And there's still going to be the difference of 35 and 17, which is 18 neutrons. That's not going to change. Did I put 18 electrons? Yes, 18 electrons, good.
Yeah.
There's 18 electrons altogether.
And if it was positive, say 2 plus.
2 plus means it's lost 2 electrons. It doesn't mean it's gained 2 protons. It has lost 2 electrons. And that will take it from 17 down to 15.
Absolutely. So that's ions and isotopes taken care of. And now to explain the 0.5.
Yeah.
So there's a lot of definitions in A-level chemistry, I won't go over them yet, but one of them is relative atomic and formula mass. And this is something you might have to work out in the exam.
Yes, yeah, and I'll give you an example in just a minute, but first just to discuss, you find lots of isotopes of different elements in nature.
Yeah.
And to find out the top number, the mass number, you would take an average of the top number to see which one's the more common, and as an average, what would be your top number.
And you call this finding out the relative, you use the relative abundance, how much of each one there is, and then you use calculations to work out what the average would be. And that's what you have to do in the exam.
Yes, so just for an example, you've got this carbon 12, carbon 13 and carbon 14, but in your periodic table it's carbon 12, so you can say these two are rare, they're rarely found. There's so much carbon 12 that these two don't really matter in finding out an average. If you find a carbon, you can say with some certainty that it's going to be a carbon 12 because there's more of them. And that's what it means to take the average of them. So now if I give you an example, just like what you'll get in an exam.
Alright, I'm ready.
I'll read it to you.
Okay. Righty.
Okay, so it's a sample of bromine.
Okay.
53%, exactly, 53.00% of is bromine 79. That means the mass number at the top is 79. And then the other 47% is bromine 81. I guess bromine 80 got lost.
That's sad.
So it says to find out the relative atomic mass of bromine.
Yeah. Relative atomic mass is just finding out what the top number should be. So Wayne, what's the first step?
Well, these are the abundances of each of these things. So the first step would be to get this out of percentage and into a decimal so that you can work with it mathematically. There's no good doing it as 53.
It's not. So to do that, you divide each number of these by 100.
Yep, so you're going to have 0.53 and 0.47. Then what you do is when you times these numbers by the percentage, it's going to give you the relative abundance of that number, how much of that number is in the overall average. So what you're going to do is divide that by 100. I'll write it all out, 53 over 100 times
the number of abundances relative to, which is 79.
And that would be your first step.
Then you'd add on the other half.
So I'll write it out fully like I did the other one.
47 over 100 times 81.
And when you add these together, it's going to give you the average relative to how much there is of each. And I don't have a calculator, but that's going to be 0.53 times 79 plus 0.47 times 81, which I can tell you,
Magical Book of Wonder,
is 79.94. Now it will specify normally in the exam to how many decimal places or significant figures.
Yeah, which is something you might need to check on.
Yep, often they'll have more than 2 different isotopes. You just do the same thing again with the percentage of the third one times the third isotopic number. And you add it together, and that's what you're getting in your table now at A level. If you look in your table, you'll notice they have decimals for some of them, such as chlorine.
Yeah, and a few others, but yes.
So next, using this, we can find out relative formula mass of compound mass of formulas and compounds.
So we don't always have just a floating element by itself. Often it's with something. So with stuff like hydrochloric acid or water.
Yes. So if we do the hydrochloric acid one, you'll notice that you look at the mass numbers of the things. Hydrogen has a mass number of 1, and chlorine has a mass number of 35.5. So when you add them together, overall you're going to have 36.5 as its relative formula mass is what it's called. Because it's all of this formula added together. You can do the same thing with something like H2O, as Triv mentioned. This time you've got 2 lots of the first one.
So it becomes 2 plus 16, which is the one of oxygen.
So it's 18. You can do stuff like NaC, I'm not going to go through all of them, H2SO4, you can do it with any of them.
But the number here just means how many times you times the number of, say, oxygen in this case, by when you're adding them together.
Yes. And then you find your relative formula, relative compound mass. That's it for this video.
It is.
I'm going to divide them into as shorter videos as we can.
Yeah.
And I'm going to think of a chemical compound that I can blow up Triv's car with.
Ah, need to get a car first.
Oh, well, I'll buy you one just to lose it.